So what I'd like to do is tell you a little about some biodegradable mulch research that we've been doing with day neutral strawberry since I started working at Washington State University in 2014. And also I want to spend some time also just simply talking about biodegradable mulches, specifically the plastic biodegradable mulches for those of you that might not be aware of this tool or technology. So we'll start at the beginning in case you're new to mulch use. So mulches are just simply physical coverings that are placed on the soil surface. They're applied for weed management purposes, and you're going to be hearing Steve Seifelt talk about weed management also in a little while today. They're utilized also to modify soil temperature, primarily here in Western Washington. They increase soil temperature, and that can be a great benefit for plant growth. They reduce the evaporation of water from the soil, so that can help with water and moisture conservation. They can also provide some protection of the soil and provide some physical covering. And overall, what we see when we look at mulches, particularly polyethylene plastic mulches, they provide a lot of benefits and promote crop growth. And for strawberries as well, when you have fruit resting on the ground, it can also provide a cleaner fruit because it's not resting on the soil. And then when we talk about mulches too, they might be made from natural materials, so straw being a very common one. That was the one I saw growing up in the Midwest, to synthetic materials like polyethylene plastic mulch, which the California strawberry industry utilizes. So we talked about plastic mulches. What about biodegradable mulches? Well, biodegradable mulches, and you'll often see them abbreviated as BDMs, they might be made from paper or plastic, and they're engineered to biodegrade in the soil upon incorporation. For the plastic biodegradable mulches, they're made with different types of feedstocks and additives, as well as other materials compared to the non-degradable polyethylene mulches, and that gives them the properties of biodegradability. To be a biodegradable mulch or a biodegradable plastic mulch, the material should achieve greater than 90% biodegradation in the soil within 2 years or less. And these are in accordance to very specific standards, the American Standards of Testing Material Standards, D598818, as well as the European standard as well. So if you're not familiar with the material too, this is just kind of a life cycle of how you might be looking at applying it in your field. So the material is manufactured with basically the same technologies that's used to extrude and make regular polyethylene plastic mulches. You can purchase it in rolls, just like polyethylene plastic mulches. In-field application also is very similar to polyethylene plastic mulches. They are a little bit more sensitive, and they can be damaged a little bit more easily than polyethylene, but you can utilize the same equipment. And then once in the field, that's where we start to see differences compared to polyethylene mulch. So depending on the material and what you're utilizing, you might get some weathering of the material, so you might see some breakdown on the surface of the soil. That's not necessarily a bad thing. That's how the mulches behave. They're going to be functionally different in the field. And then once you're done with your production cycle, and this is thinking about an annual production cycle, they're meant to be tilled in the soil, and that's where the fragments of the mulch are supposed to be acted upon by microorganisms in the soil that consume it as their carbon source, and thus the material should go away. That makes it biodegradable. So why consider it, and why are we interested in it in our research program? Well, they are perceived to be a more sustainable technology, particularly if they provide some of the same benefits as polyethylene plastic mulch, but then might reduce some of the labor and cost associated with mulch removal as well as mulch disposal, because that can be a rather costly activity when finding the labor to remove it, as well as then trying to find a place to dispose of it. There's cost associated with that. And in turn, this might promote some on-farm efficiencies and offset the higher costs that you do pay with the biodegradable plastic mulch compared to polyethylene mulch. And then also, there's this goal, can't see the last bar there, but there's also this goal or this awareness that we're becoming more familiar with, and that's trying to reduce plastic waste generation in our environment. And I think that's something we're going to hear more and more about, talking with folks in Driscoll's as well as Nature Right. There are sustainability initiatives looking at alternatives to plastic from field as well as to packaging, are certain things that are on their radar. And so it certainly also is something that it's in the public awareness. And I think we're going to be more and more concerned and looking at ways to reduce plastic use in both production as well as in packaging and agricultural systems. So agriculture is a heavy plastic user. We use like about 1 billion pounds of plastics annually. A lot of this is nursery containers, followed by livestock feed. But then third are plastic films, such as in high tunnels or plastic mulch films. Most of it that we know from surveys and work by people that work in the plastic waste industry, it's stockpiled or landfilled, sometimes even soil incorporated and burned. That's allowed in certain states. Right now, less than 10% of that material is recycled because it's a highly contaminated material with soil on it. So it's very difficult for recyclers to take. And we also have countries like China that are used to be taking plastic waste for recycling, but they're taking less now. And so this leads to environmental waste challenges that we have and provides another motivation in terms of why we might be interested in biodegradable alternatives. So Washington State University has a long history of research working with biodegradable plastics. Dr. Carol Miles, who is a vegetable extension specialist and vegetable horticulturalist at the Mount Vernon Research and Extension Center, has been working with biodegradable mulches for about 20 years now. And so when I came on board, we started collaborating right away, looking at utilization of biodegradable mulches in state-neutral strawberry production systems. And we published some papers on it, and there's also some publications that are geared towards growers and their extension fact sheets. So if you're interested in that, you can either find them on my website or just contact me directly and I can give them to you. And we also have graduate student Juan Zhang, who's been working with biodegradable plastic mulches in red raspberry systems. So what we've done in strawberry, we've done 2 experiments so far. One is completed and one is ongoing. And the objectives were to look at commercially available biodegradable mulches and 1 experimental prototype and compare it to standard polyethylene mulch and bare ground cultivation in both spring and fall planted day neutral systems in northwestern Washington. And these were experiments that were conducted at the Mount Vernon Research and Extension Center. I'm going to jump right into the results and not really explain the trial. It's something you can ask me about later on just because of the time constraint. But these are the results from our first experiment where we utilized spring planted bare root Albion and Seascape strawberry. And so I'm just presenting the yield data here. And what we found, well, let's walk through this table first. Our treatments, the top 4 here in this particular trial, the first 3 are biodegradable plastics. So you'll see here, Bio360, Weed Guard Plus, that is a paper-based material. And we had an experimental prototype that we also had in the project. And we compared that to plastic polyethylene mulch and then a bare ground control. So when we look at marketable yield per plot, and we'll just focus on 2014 and 2015 data. Let me get the pointer here. So we see that on average, when we look at the plastic mulch, what we see that we don't see any differences with the biodegradable mulches compared to regular polyethylene mulches. They're pretty much similar with a few exceptions. We did see Weed Guard Plus in 2015 have a yield that was lower than the biodegradable and polyethylene plastic. The other thing that I want to point out with the Albion is that the bare ground had the lowest yield compared to all of the mulch treatments. And we see that consistently. If we look at Seascape, we see fairly similar results. We see that all of our mulch treatments in 2014 were similar, and we had one of our experimental biodegradable plastic mulch alternatives yield higher compared to bare ground. And then in 2015 also, we saw the polyethylene leading to higher yield compared to our other treatments. So the take home here and what we see consistently in some of our other experiments as well as in vegetable cropping systems is that the biodegradable plastic mulches perform the same or similarly to polyethylene plastic mulches. And then the bare ground controls, we tend to see yield depressed. And that's likely due to weed management because we do see reduced weeds with plastic mulches, both biodegradable and non-biodegradable, and also to a soil warming effect. And we don't necessarily get that soil warming effect with the paper-based mulches. They tend to be a lot cooler and more similar to the bare ground. So experiment 2, this is a WSDA funded project that we have with Wendy and Pat Moore's program. Here what we're looking at is fall planted plugs of Albion, and we only have 1 year of data from this, and the data that we're collecting for 2019 and to 2020 is ongoing. But what we're looking at here is yield of fall planted Albion plugs I'm presenting this as grams per 20-foot plot. And our treatments were a biodegradable mulch. This was Bio 360, the same material that we used in our first experiment. Then we utilized a green mulch. So this is a woven polyethylene material, very similar to weed mat, just a green color. The manufacturer was very interested in testing this, and we had heard in Europe that the green material helps promote yield. And then we had the polyethylene, and here we didn't have a bare ground control in this particular experiment. What we see among all of these treatments is that yield was the same. We didn't see any statistical differences. So that's one thing to take away again, is that the biodegradable performed very similar, or pretty much performed the same as the polyethylene. And then we're interested in this green mulch material because, as we hear from Mike and others, there's interest in having day neutral plantings last longer than a year. So this might be something that could provide some longer mulch control. It isn't biodegradable, but it could be a tool that would be useful to these growers. So a few things that I wanted to also educate you about biodegradable mulches in case you're interested in this. Number one is that they are not all created equal. They are made with different types of feedstocks, materials, additives, manufacturing processes. So what one biodegradable mulch does might be very different than another company's biodegradable mulch. So that's something to be aware of. And they function very differently. Also, I think it's important to do trials here in the Northwest because we see a lot of effects due to the environment, particularly when we're looking at in-soil biodegradation, which I'll touch on in a moment. But when we look at some studies that have been done in Tennessee, matched with Northwest Washington, and this has been in pumpkin and sweet corn systems, but they look at biodegradation in the soil, and we see almost complete biodegradation for many of the materials in Tennessee soils that are warmer, where we see almost very little. So it's very different, and they're going to behave differently in terms of biodegradation in the soil based on the environment. And what we've seen in our experiments is that not all biodegradable mulches have demonstrated complete biodegradation in soil. So that's something we're concerned about, and it's also something we're looking at, is if there's ways that we can apply a treatment on top of the biodegradable mulch material to really initiate and accelerate that biodegradation so you don't have plastic materials in your soil. And here's something, this is from Juans Experiment. He's a graduate student working with biodegradable mulches in red raspberry production systems. And we're also interested in biodegradation in that situation as well. So what he did in April of 2018, he took biodegradable mulch materials, one made from BASF and one made from Bio 360. They're both large biodegradable mulch manufacturers. He buried them in these mesh bags, some with soil, some without soil, and he buried them in the soil. And every 6 months, he excavated them and looked at biodegradation to see what's actually happening. Are they performing as they should? Well, this is some images from some samples he removed about 1.5 years after he buried them in October of 2019. And so you can see these materials are pretty much intact. We're not seeing the biodegradation that we were hoping to see. So that's something to be aware of and something that we're concerned about. Another aspect too is OXO Degradable Plastics. These are often sold under the label of biodegradable plastics, but they are not truly biodegradable plastics. They don't meet the same standards. And from a material standpoint, they're conventional polymers, so plastics with chemicals added to accelerate what we call oxidation, basically fragmentation. So what these materials do is they're not being truly biodegraded by soil microorganisms and being removed from the environment that way through microbial action. They're actually just fragmenting into smaller and smaller plastic pieces. So there you're dealing with microplastics in your soil. In fact, Andy Berry, who is a soil scientist in Puyallup, there's a field nearby, and he noticed that they had applied OXO degradable plastics, and after 3 years you can still see a lot of plastic fragments that are remaining in the soil. So something to be aware of, and there's questions you can ask if you're interested in biodegradable mulches to help discern if what you're looking at is truly a biodegradable material that meets the standards or if it's not. And then lastly, if you're an organic producer, also be aware, because in 2014, although the National Organic Program added biodegradable plastic mulches to their list of allowed materials, they have to meet 4 criteria in terms of the standards being bio-based, degrading within 90% or less in 2 years. And as of right now, and based on our research, none of the plastic biodegradable mulches available on the marketplace meet those standards. So if you're an organic grower, talk with your certifier, but we would not recommend utilizing biodegradable plastic mulches in your operation because none of the materials tested to date meet these standards. Paper, on the other hand, does, so you could use paper. So with that, I'll wrap up, and looks like I'm leaving a little bit of time for questions, but I do want to acknowledge several individuals. So Wendy and Pat with the WSU Small Fruit Breeding and Genetics Program for their collaboration and provision of plant materials in one of our experiments. Charlie Gunderson with NorCal and Planasa, who also provided plants for our experiments. The Washington State Department of Agriculture Specialty Crop Block Grant Program, and Washington State University Emerging Research Issues Program for providing funding. Also, all of the student helpers that help with planting and weekly harvesting and all the different field activities. And then I'd like to acknowledge many of the co-investigators on this work, Juan Zhang, Carol Miles, Suresh Gamira, and Sean Watkinson. So with that, I believe I should have a few minutes for questions. Yeah, Wendy.
When you use the green mat, were you able to utilize your same bed shaper? Would it work to stretch it over the bed?
Yeah, so the question was, when we utilize the woven material, which is, again, pretty much identical to like a weed mat material, only green in color, could we use our rainflow mulch layer? And the answer is yes, we could use it. It worked beautifully.
Okay. Yeah, keep doing the work. I need a biodegradable mulch. I pulled mulch up on a piece of that didn't make it. Had Vert take it out, and there's way too much mulch in my soil that I like, just in a 1-year deal. And I'm trying to be sustainable on the same piece of ground and figure my rotation out. So, but I also need a biodegradable mulch that's 4 or 5 years. I mean, that's what I'm looking for. That's what and maybe the raspberry trials, if they keep it, we can see. But definitely we need something that breaks down in the soil, because I haven't figured out a way to get it all out. Okay. And the 2, did you have less sunburn?
So,
on the green, did you have less sunburn on the green mulch than you did on the black mulch?
Yeah, so the question about sunburn, no, we did not see any differences in sunburn in the green versus the black mulches. Okay. We're still in the middle of doing our fruit quality assessment, so we'll look more at sugars and acids, but we didn't see sunburning on them.
And do you have a temperature probe?
We did have a temperature probe.
And,
yeah.
And what was the temperatures on?
Ooh, I have to go through those data. You're going to put me on the spot there, but I believe they were fairly similar, just looking at the general means there. Really, when you look at temperature differences, the greater difference really is between mulched and non-mulched. It's not so much the type of mulch at this point that we're seeing. That's the greatest differential. And then another point too, Mike, you made about more multi-season biodegradables that last for a longer production cycle. We are currently doing some experiments with raspberry, and the goal would be, if we find something that has longer durability, that could be transferable to a raspberry production system. So stay tuned, and hopefully we'll find something that works for growers. Oh. Okay. All right. I'll catch you later, Tom. All right. Thanks, everybody.